So we're going to do another advanced mechanics question. Here we're told a missile is launched. So this is a new question. A missile is launched at a velocity of 300 meters per second at an angle of 35 degrees up. How far does it land from its launch position? Okay, so we're going to draw a diagram of this. We have an object launched from the origin, follows a parabolic trajectory and then lands. So it launches at the origin. This is our y-axis. This is our x-axis. Travels for a while and then lands. The initial velocity vector has a magnitude of 300 meters per second and it is 35 degrees up. So this means the angle is 35 degrees up from the horizontal. How far does it land from its launch position? Okay, so we're going to use a short formula for this. The x maximum in any parabolic trajectory is equal to minus 2 times uy divided by g times ux. So this formula can be derived just by using fundamental kinematics to set up the x max as a function of the other variables. Note here that u of y is the initial velocity in y and u of x is the initial velocity in x. Now this formula makes sense because if you launch something this is one of the reasons it makes sense. If you launch something directly up, it has no initial velocity in x, so u of x would be 0, then the distance traveled would be 0. Similarly, if you launch something directly across, it would have no initial velocity in y, and so it would essentially not go anywhere. It would just stay where it was. So we need some information here. We need the initial velocity in x, the initial velocity in y. We know g is minus 9.8. So initial velocity in x, we can find ux and uy using trig. So we're going to have sine of 35 is equal to uy over 300. This implies initial velocity in y is 300 times sine 35. And then we have cosine of 35 is equal to ux over 300. This implies that ux is equal to 300 times cosine 35. We'll plug this all into our x max formula. The x max is equal to minus 2 times 300 times sine 35 times 300 times cosine 35, all divided by minus 9.8. So we put this whole thing into our calculator. Minus 2 times 300 times sine of 35 times 300 times cosine of 35, all divided by minus 9.8. This gives me x max is equal to 8629.83 dot dot dot. So therefore the x maximum for this question is going to be 8629.83 to 2 decimal places, and that is in meters. So this is how far the projectile travels, and we found this using this short formula up here. X max is equal to minus 2 times u of y over g times u of x.